Good evening, all. I welcome you all for the day 4, session 4 of an AMPET sponsored short-term online course on power electronics converters applications in microgrid and vehicular technology from 20th July to 24th July 2022, organized by the Department of Electrical Engineering, National Institute of Technology, Rourkela, Odisha, India. Now, the tutorial session will be handled by Mr. Allu Bhargav, who is a PhD research scholar at the Department of Electrical Engineering, NIT Rourkela. So I welcome Allu Bhargav, sir. Please take over the session. Thank you.
Thank you, Kartik. Am I audible, Kartik?
You are clearly audible. Sir. Can continue the session.
Okay, thank you. Let me share my screens and just confirm me whether my my screen is visible.
It is not yet. Can you please do it once again?
Okay. Is it visible now, Kartik?
No, sir. Please do it once again.
Oh God. Give me some. Sorry for that. Just wait.
But then you can see that share option. Please try to do it.
Yeah, I'm doing. Just wait. Okay. Is it visible now?
No, not yet, sir. Actually, it is not starting also.
Just give me a minute. Okay.
So now it is, we are able to see, sir. Please.
You're able to see now?
We are able to see. Please share your presentation. We are able to see your screen now. Please select your presentation.
Okay. Are you able to see my slide now?
Yes, sir. Yes, sir. Now it is clear. Please make it full screen and continue.
Is it okay now?
It is perfectly all right, sir.
Thank you, Kartik, for your cooperation. Good evening to everyone. I am Allu Bhargav, research scholar from Department of Electrical Engineering, National Institute of Technology, Rourkela. Today, I am going to present a tutorial session on electric vehicle battery charging application. Now, coming why electric vehicle? We are observing that there is a continuous rise in global temperature day by day due to high usage of fossil fuels and due to its emissions. Most of the fossil fuel consumption is from oil used for transportation. As per statistics, 49% of oil is used in road transportation. In order to reduce this global temperature rise, we need to find alternative solution to the oil usage in road transportation. Researchers and scientists suggested that electric vehicle will be a best alternate solution for road transportation. So let's see what are the advantages of electric vehicle compared to conventional IC engine based electric vehicle. First, coming to energy efficiency. The energy efficiency to charge the EV for 1 kilometer will be a 1/3 of fuel energy required for the same vehicle. That means that we can conserve 2/3 of energy, which will improve our energy efficiency. Energy security. And as we see the graph between oil production and oil consumption for a few decades, oil production in future, oil consumption going to dominate the oil production, which will be a threat to energy sector. In order to secure our energy sector, EV will be a best solution. Now coming to no air pollution. As there is no tailpipe in a fully battery vehicle, there will be no emission of gases in the air. Greenhouse gases reduction. As there is no greenhouse emission, there is no emissions into air, no release of CO2 and O2 gases, which are greenhouse gases. This is the main advantage of EV vehicle. Noise reduction. Compared to IC engine vehicle, EV produces very less noise. Next, coming to cheaper maintenance. As in fully electrical battery vehicle, there will be a battery and a motor and absence of IC engine. So there will be no requirement of lubricants, which leads to cheaper maintenance. In addition to it, EV produces very less vibration, which will be as benefit of human beings. Now let's see different type of electric vehicles in the past. Coming for there are 3 types: hybrid electric vehicle, plug-in hybrid electric vehicle, battery electric vehicle. Now, what do you mean by hybrid electric vehicle? Generally, this hybrid electric vehicle, it can be powered by both gasoline or diesel or petrol and battery system. Here the vehicle will alternate between two things, either diesel or else battery to maximize the efficiency. The main disadvantage in this hybrid electric vehicle is that battery can be only charged through the conventional engine, and energy generated when accelerating or braking will be utilized to charge your battery. So when coming to plug-in hybrid electric vehicle, these are versatile hybrid vehicles in which battery can be charged by both IC engine and electricity grid, where the outlet will be presented in the vehicle. And coming to battery electric vehicle, these are also plug-in electric vehicles. They are exclusively work on battery power, which needs to be recharged by battery connecting to the electric grid. And these do not emit pollutants, and they are ideal for short urban journeys. But in plug-in electric vehicles offers great range than fully electric vehicles. So in order to improve battery electric vehicles usage, we need to make our charging systems availability in everywhere. So this will be our EV charging system. And here we can see that 3 pointers will be given to everywhere, will be present for the vehicle. And every first one will be there are 3 types of battery charging levels. One is level 1 charger, level 2 charger, and level 3 charger. Level 1 charger will be range from 1.12 and 3.3 kilowatt, and level 2 charger will range from 3.3 kilowatt to 22 kilowatt, and level 3 charger will be range from 22 kilowatt to 50 to 100 kilowatt. And here we can see that when plugging, when battery charger will be plugged into the supply, the AC/DC converter will be initially it will be connected to AC/DC, which will rectify our AC to DC, and PFC converter will maintain power factor correction, and from there we can see DC/DC converter will be connected, which maintains DC voltage to the required voltage. Now from here, after rectifying the DC from DC voltage, the power flow will be flown during charging system. Power flow will be grown to battery pack, and during running condition, battery pack will discharge its power to electric motor through inverter traction drive, and any light loads like electronic loads, lighter, heater, or as auxiliary loads will be supplied to a unidirectional battery charging system. And here the power flow can be to DC-DC converter. And here we can see that this will be a unidirectional DC-DC converter, and this will be a bidirectional because when there is any braking or decelerating, it can be used as a regenerative power. You can regenerate our power and supply power back to the battery pack. And here the battery charging system is complete will be a battery charging system which can be a unidirectional or bidirectional. In case of unidirectional, it can be enable only grid to vehicle, and in case of bidirectional, we can enable both grid to vehicle and vehicle to grid. Now coming, let's assume that we have rectified our AC to DC, and we have a constant DC voltage which is required. And from here we see what are the different type of EV chargers for after DC-DC convert. After rectifying our DC to DC, there are two types. One are non-isolated and isolated. One is in case of non-isolated, buck boost, interloop boost, cup converter, cascader. And in case of isolated, we can have dual active bridge, triple active bridge, dual up bridge, and half full bridge. And what are the operations and advantages of isolated the DC-DC converters have been explained in the previous session by Dr. Indra Sarkar. And now I'm going directly going to the dual active bridge, because dual active bridge is commonly utilized for DC-DC charger. And this is the operation of this is the configuration of this dual active bridge converter. Here we can see a constant DC voltage source has been maintained after rectifier, and that will be connected to H bridge, primary H bridge, and this is the secondary H bridge, and these two are interlinked to a high frequency transformer, and there will be this is the leakage inductance this is the leakage inductance of the transformer, which is denoted by inductor, and from output of the secondary H bridge will be connected to either resistive load or a battery. Now we can now let's go to operation of the dual active bridge converter. We know that the dual active bridge generally the operation will be based on phase shift between two voltage waveforms produced by two bridges. See here, sorry. Here, in order to rectify, this will be inverting our DC to voltage and will form a square waveform across this inductor, or else you can say transformer, across the primary of the transformer. And this square waveform will be induced here, and this square waveform will be rectified to DC voltage. So so the operation of it will be governed by phase shift between these two voltage waveforms. The operation will be governed by these two waveforms. Governed by phase shift, there will be phase shift between this square waveform and secondary square waveform, and each bridge will be controlled with a constant duty cycle of 50% to generate high frequency square waveform. These two square waveforms are appropriately phase shifted to control the power flow from one side to another. Power flow will be from leading side to lagging side. Like when we have a square, two voltage sources are connected to two voltage waveforms and having a phase shift between them. So power flow will be equal to P equal to Vs Va by XL into sine phi. So this concept will be utilized here same in the dual activities. And what are the different control strategies of dual activities? There are four types of control for dual activities. One is single phase shift control, external phase shift control, dual phase shift control, triple phase shift control. But basically, the SPS control will be mostly commonly utilized because it is more simpler compared to others. And the remaining dual activities and triple phase shift controls are a little bit more complicated and difficult to implement. Now let's see single phase shift control of dual activities. SPS control with conventional control method we generally utilized because of simple implementation. And SPS control will be having it will produce a single phase shift between two H-bridges square waveforms. And as the transformer will be having no phase shift and only we need to give external phase shift. There will be no internal phase shift, and output power can be controlled by using this formula. P equal to V1 V2 into D into 1 D by 2NL, where V1 is the input voltage, V2 is output voltage, TS will be 1 by Fs, where Fs is switching frequency, and N will be transformation ratio, L will be leakage inductance, and D will be phase shift ratio. And these are the waveforms of SPS control of DAB. And here we can see that S1 initially when S1 S4 is on, and S5 S8 will be having a delay of 5. And after that S5 is still on, and after pi we can see that S1 S4 is off and S2 S3 will be on, and after pi plus 5 you can able to see that S6 S6 will be on and S5 will be off. And during this operation, VPV, this is the primary voltage of the primary voltage on the side of transformer, and this is the secondary side of the transformer secondary side voltage of the transformer, and this will be leakage inductance current. And here we can see how we get this. Initially, when we have here, we can see that VPV is positive and this is Vs. So IL will be equal to Vp minus Vs by L. So here we can see that VPV is positive and Vs is negative. So slope will be a little bit higher. So there will be continuous rise in current. We having higher slope and rise will be faster. Now when coming to after pi. Now here we see VPB is positive and Vs is positive. So the slope will be a little bit lower, and there will be and VPV is higher greater than Vs. The slope will be positive, and the current will be slow a little bit because the slope will be reduced. And now coming after pi, you can see that VPV is negative and Vs is positive. So we can see so that due to this there will be negative slope, and the fall of the leakage inductor current will be faster. And after I plus 5, you can see here the VPV is negative and Vs is negative. So and the output and the slope will be still negative, but the slope will be a little bit lower. So the rate of the fall of the inductor current will be a little bit lower, and you can see the fall. Now let's see the tutorial session of DAB control in the MATLAB session in the MATLAB. Karthik, can you give me confirmation whether my MATLAB is visible or not?
Yes, yes, sir. Your visible, sir. Your screen is visible.
Thank you, thank you. So this is the MATLAB 2020 version, and here in the simulink we are going to simulate our dual activation converter model. So we need to open a blank model, and this is the blank. This is the model. This is the simulink blank model where we construct our DIB. So now let's analyze how many components we require for this dual activation construction. First will be a DC source. The next switches, which are quantity 8, and the transformer and an inductor, and input output capacitances, and resistive load. So let's take our elements from the library session. So this is the library browser where we can find our elements, and selecting finding the elements will be two types. One we can search here, or else we can go to SimSpace, some electrical and specific power electronics. You can see here fundamental blocks, electric sources, and this is our DC voltage source. And one more way of searching the components is that we can able to search directly the component name IGBT. I'm taking the 8 IGBT, so
Sir, we are unable to see your Simulink file.
okay, I'm sorry.
It's okay.
Are you able to see my screen now completely?
Yes, 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 sir. Now.
Yes, yes.
Okay, fine. Let me starting again. How to library project. So from here we can see this is library project. So first initially there are two ways to check our elements. One it will be like going to SimScape, and from there electrical, and from there specific power system elements, and from there electric sources. And here we can find our DC voltage source. And one more way to find our elements will be directly finding by typing our element name. So I'm searching IGBT. So you can check here. Sorry. And here we can see there are many various types of elements we form, but you see here there are two types of IGBTs, and we are taking IGBT with feedback diode. Think see this is the DC source which I got, and this is the element which I got. And what elements we require? We require a transformer. Next, what else segment we require? RLC see here, one more thing I need to tell you that there see here we have one transformer like linear transformer, and one more transformer also we have variable ratio transformer. So we see what is the difference between these two elements. See here in linear transformer we have three windings. As of now we require only two windings. So we'll remove this checkbox. We'll remove out of the checkbox 3-winding transformer, and we'll apply. And you can see there are only two windings has come now, and third winding has been removed. Now let's decide what is the nominal power and frequency. So let's take I'm using power of 8 kilowatt, like 8,000 VA, 8,000 VA, and operating frequency will be some 25 kilohertz. And winding parameters are right now I'm taking V1 will be winding parameters, VRMS will be 400. And right now I'm taking all R1 and L1 0, and I will denote the leakage inductance outside with inductor. So as I said, the leakage inductance will be denoted by inductor outside. So I will denote there. Right now, I'm making these total methods 0. To 60. And there is one more thing. This is the variable ratio transformer. Here you can see that only we have able to only give what is the ratio from outside, from external. We have no control over the windings and voltage parameters. So we don't require this thing. We require only this transformer. And here you can see here the IGBT having 4 ports. One is collector, one is emitter, one is gate, and one more is in measurement port. So through this measurement port, we can able to see what are the voltage stresses and current stresses. I'm constructing now 2 H bridges.
Participants, please mute your mic, please. Okay, continue, sir.
Okay. I'm now constructing my bridge now. Now primary H bridge construction done, and now I am constructing second H bridge. I'm just copying it in. And there is one more method way to check our to get our elements. We can just double click on left button of mouse, so we get elements. We can check here RLC element we require now. So there are 2 types of RLC branches. Here we have series RLC load and RLC branch. So let's see what is different between RLC branch and RLC load. So in RLC load, we are having nominal voltage and frequency and power, reactive power and reactive power. So in case of RLC branch, we can able to denote RLC. We can able to define our RLC components. So currently I am considering only RLC branch to give input capacitance. I'm taking capacitance of capacitance. I'm taking. I forgot to connect leakage inductance. So sorry. Now Now we are done with H-bridge. Now let's construct now how to control this gate pulses and all. Now I'm taking it up. Now we need to generate 50% duty cycle where pulse generator for this primary H-bridge and secondary H-bridge. So let's take now pulse generator. Now let's define it. What is the amplitude and so what is the period of seconds? So it should be period of our switching frequency. I'm taking right now 25 kilohertz as my switching frequency. So period will be like 1 by 2500. And what is the duty cycle will be 50%. So I need to give pulse from here to here, S1 and S4. So I will use go to and from to blocks. And from to block I can drag like this. So I'm giving to S1 and make it global. Similarly, we can give here S1 given to switch on. Now again S4. So I need to define now S4. Now again test. Now I need to give S2, S3. So I need a NOT gate. So we can here give the logical operator. So we need only NOT gate. Different type of logical operations we can perform by the clock. So we go to NOT gate. So I'm using NOT gate only. And from here I'm giving to. So we like. And will be given to S2. And now we require one more S3. You can follow up on here. You can do this. Similarly, now we need to get pulses from for this with a phase shift. So how do we get phase shift? Require a delay block. Delay. We require discrete delay block. We need to search where it was. So we are having time delay and how much time delay we need to give our system. So we give maximum from 0.5 seconds. And we get a signal small delay from here. We getting the signal, this is the input and this is time delay which we need and this is the output of the block. And now similarly we need the same thing out how many blocks we require. So we require S5. Similarly we require a NOT gate. And again we require S7, S8. S8. So everything is done. Now we'll make it a block. So control G. And this is the input. This is the input of time delay. We need to give this is make entire system make into subsystem by making selecting all the components and making control G. Now from here we can give input. So we will denote as delay input. So we go to system there. Now we need to generate our delay. So how we generate our delay? So we'll sense a voltage current. We will sense our output voltage. So we need voltage measurement. And we see scope. And we sense Now go to conclude. Go to let me get V not distance. Now we need to maintain a constant voltage. So constant block. But to maintain outside and the output at 60. So I'm making it. So in order to maintain this control, in order to maintain 360 degrees, I require some controller. So I'm choosing PI controller. So I require only PI, not require D. So I'm making one. From the characteristics of PI, you can say that maybe 100. Plus will be addition. So what do you mean by this delta? If you cleanly observe my PPT here, see this what is the delay will be like delta TS by 2 pi. So here you can see this in this TS and 2 pi will be apart and this delta will be generated. What is the delay? The delta will be generated by this PI controller. So from delta we need to calculate our yeah. And after generating the delta, I need to add multiply this TS by 2 pi. So I'm adding. I need a gain. So I already know TS will be 1 by Fs. So 1 divided by 25 kilohertz into 2 into Pi. And that will be generated and will be given to now what does we require? We require power G block. I prefer discrete. I 7. Sorry, about to eight. Karthik?
Sir, we are able to see blue screen.
Okay, just wait a minute, there is something happen.
Yeah.
Chal. Give me 5 minutes. I'll open.
So please try to share the screen once again.
Karthik, give me some time. Give me 2 minutes time.
Okay, sir, you can take. No problem.
I'm sorry, there is a crash in my MATLAB. I'm reopening it again. As I constructed my model already, I will open that model and I'll run it and I'll show you. Is my screen is visible?
Yes, sir, it is visible. You can continue.
Okay, thank you. I already made the model, so I'm reopening the model. This is the model which I made, which I constructed now. You can see here. and running the model. Sorry, let's see. Now we can see the output voltage here. I have asked to maintain at 360 degrees. It is maintaining 360 degrees. And now coming to, let's see what are the things going to see. Let's see what is the D value. So it is maintaining 45 degrees. So it will be 45. And here we can see the primary voltage and secondary voltage. And here we can see the phase difference. This is the primary voltage and this is secondary voltage. Here we can see the phase shift. The phase shift between primary and secondary. Due to this phase shift, the power will be flown from primary to secondary side. And here we can see inductor voltage. And this is the inductor voltage. Here you can see the current of inductor, leakage inductor. Okay, let me show you whether my PI control is working perfectly or not. So I will take a step response. Instead of constant, I'm giving step response. I'm giving initial value to 360 and final value from 320. And I'm making it run.
So meanwhile, I have one doubt. May I?
Okay, ask me.
So generally this PI controller tuning we can do like manually and automatically. Two most things are there, no, sir. Could you
See,
please
there are
explore thing on that if you have an idea?
Yeah, actually during PI controller, if you want to do manually, then you can use Nicholas method by initially tuning P, and we check whether output will be stabilized or not. Then we give our I value, then we can see the output whether it maintains constant or not. If you want to do automatically, means like you need to make a transfer function of the system completely, and you need to draw Boolean plot or Nyquist plot, and from there you need to analyze stability analysis, and from there you need to get these PI values. As the session is only 1 hour, I can't show everything, how I draw, how I took the small signal analysis and all. So right now I've given directly the values of PI, but you can able to find the analysis from any IEEE papers. The many people propose how they did transfer functions, small signal analysis from the IEEE papers.
Yes, sir. Thank you so much, sir. And I think we can also use that PI tuning app.
Basically, I never used a PI tuning app, but mostly I think it can be useful. And here you can see. See, I given initially 360 at 1, and I asked to maintain at 320, so it is maintaining 320. At 320 is maintained, and the phase shift is there is a little bit change in phase shift. And you can see the values of there is a phase shift between primary and secondary. And this will be inductor current value, and you can check it out. This is the inductor value of, and you can see output current. I didn't show initial output current. You can check it output current. So at initially it was 360 by 20, it will be giving some 18 amperes. And when now it is increased to 320, so it's given 16 amperes, and it will maintain 16 amperes. With this, I'm closing my session. And these are the parameters which I have used for previous some DAB. With this, I'm closing my session. If anyone has questions, you can ask me.
Sir, why have you used variable time delay?
See, in the time delay will be changing every time. We can't do a fixed time delay, right? So the variable time delay should be given from outside. So in order to give, wait, let me show you that. See here, see, this delay may change every time, and the time delay will be changing every time. It cannot be constant delay. So in order to give output input as some variable delay, I use variable delay block.
Okay, so considering the practical conditions, the parameter could be fluctuating.
Sorry?
Considering the practical conditions, the parameter could be fluctuating. So to generate that fluctuating parameter in simulation, you use variable time.
Right.
Is it?
Yeah, right now, I didn't consider any practical conditions. I need to implement it. I didn't implement. Once I implement, I may know what are the issues right now. Any other questions?
The participants can interact with the speaker if you have any queries regarding how he has developed the mathematical model and in his presentation. Have any queries? So there is one query in the chat box. Let me read it for you. How to design a distributed generation system in MATLAB?
Actually,
how to design a distributed generation system in MATLAB?
Right now, distribution generation system Like what you want to generation, like if you want a combination of PV and wind and battery system, or what you want?
I request the participants to please unmute your audio and ask your query in detail so that the speaker may help you.
Right
Could you please
now,
speak?
no, I got it. He made me more in the chat box. Right now, I don't have that much idea. I'm just started my research work, so will be out of my scope right now. So I can't answer this question right now. Sorry for this.
Any more queries from other participants? Sir, I think there are no more queries. I think with your permission, we can close today's tutorial session.
Yes, yes.
Thank you, sir. Thank you for your valuable session and sharing your knowledge this platform.
Sir, when will be the link of this today's session will be shared?
Sir, sorry, could you please repeat it?
Yeah, link of the today's YouTube link of today's sessions.
It will be shared very soon, sir. It will be shared very soon.
Sure. Thank
It will be posted in your WhatsApp group also. We will share it.
you. Okay. Thank you.